Good morning, good afternoon, good evening, based on where you are. My name is Nagesh Pachula. I'm the product manager for Global Data Services. What we will do today is we will cover what GDS is and how it addresses the use cases for Oracle GoldenGate. As you all know, GoldenGate is the logical replication that allows you to replicate data from a source to a target. Right? So when you're using GoldenGate replication, whether using active-active or whether using a read-farm kind of a configuration, how does GDS help you in achieving maximum performance for your application, maximum availability for your application? Right? We'll cover all those topics and specifically focused on GoldenGate today with GDS. Okay. All right. Agenda-wise, we'll touch upon what are the challenges while managing the workload across replicas. And we'll talk about how GDS addresses those challenges. And then we'll take a look at the use cases, how GDS is applicable to GoldenGate. Okay. So now before I touch upon what GDS is, let's talk about those challenges when you're using replication technologies. Right? In this example, I have two databases, a master and a replica, a source and a target. They could be in the same data center or they could be in different data centers. So now, in this scenario, without GDS, you don't have an automated load balancing, which results in suboptimal resource utilization, wherein you have underutilized resources on one of the data centers and an overutilized resource on the other data center or the other database, and you couldn't leverage the free resources that are available in the underutilized server to offload the work of an overutilized database server. Right? So that's a challenge for many of the DBAs prior to global data services. So that's one of the pain points. The other pain point is there is no automated global service failover across databases. So in this example, I have two databases again. I'm running my workload on the replica. Let's say in this case, it could be a read-only workload on the replica, right? If that replica goes down, there is no automated way for me to move a service from one database to another, right? So without which you will have application outages and there's no service high availability. Okay, and there are many other pain points. I'm just highlighting a couple of them. So now, as part of 12.1 Oracle database, we have introduced a new feature called Oracle Global Data Services. What it is a mechanism, it's a vehicle with which you can seamlessly and automatically manage your client workload across replicated databases. Okay, so if you see, if I had to step back a bit and see in a rack database, right? We have a concept called service, with which you can have a service level failover across instances of a database, or you could even have load balancing, whether it's connect time or runtime load balancing across those instances of a cluster database, right? But it's all within the scope of one cluster database. What we have done as part of GDS is we've extended that notion of a service, a notion of the database service, to replicated environments. Right? So essentially, we created a new concept called global service, which will offer you service level failover, connect time load balancing, runtime load balancing across databases. And these databases could be in the same data center, or it could be in multiple data centers. And these databases could be rack databases or also single instance databases. Right? So that's global service as a concept that allows you to achieve the failovers and load balancing. So now, the capabilities of GDS-wise, it allows you to achieve routing based on the workload, based on the locality, basically the region, or replication lag. In the case of Active Data Guard, we even support routing based on replication lag. The second capability is the service level failover. We talked about this. If a database goes down, GDS will automatically will fail over that service to another copy of the database, so your applications can continue to function. Okay. So key benefits, number one, GDS allows you to maximize your application performance. It provides you, like I said, connect time load balancing, runtime load balancing, locality-based routing, right? With all these features, it allows you to maximize your application performance. It allows you to mitigate your downtime, whether it's planned outage or unplanned outage. It allows you to minimize the downtime, and I'll showcase how it's done. And with simple policies, you can set and achieve this, this benefit. The last one is you could have numerous replicas, and you could have DataGuard or GoldenGate for that matter. You can manage all these replicas with a single interface. It could be a command line interface called GDS CTL, or there is a GUI version of it via EM as well, Enterprise Manager. Right? So with one interface, you can manage your client workload based on your business policies. Right? On the right-hand side, what I'm showing here is with GDS now, you'll have balanced workload distribution across these databases. And also you will have service level failover. If a database crashes, you automatically fail over the service to another data center and let the clients know to connect to this database, which is currently offering that particular service. Okay, so that's in a nutshell what GDS is. In terms of the architecture, this is the architecture that illustrates the components as well as the mechanism of how GDS does these capabilities. Let's talk about this. So there are three layers in this. At the top, you have the application tier. At the bottom, you have the database tier. And these databases could be using GoldenGate or DataGuard, as I said. And then in the middle, you have this GDS layer. It has a couple of components in it. One is the catalog. The other one is the global service manager. Catalog, think of this as a regular Oracle database, which persists the metadata of your GDS infrastructure, the databases, the data centers, all the logical information. What are the services offered, and what are the policies that you set? All that information is persisted in the catalog, and we recommend that you replicate that catalog with DataGuard to another database and another data center. Right? It's no different from your EM repository or RMAN catalog. It's very similar to that. It's a small scale catalog database. Right? The other component is the global service manager. GSMs, it's also called as. These are instrumental in providing the GDS capabilities, whether it's connect time load balancing, whether it's runtime load balancing, whether it's service failovers. All these capabilities are executed by the global service managers. Think of them as global smart listeners, very similar to your Oracle database listeners, very similar to your scan listeners in the case of RAC. Now, with a GDS infrastructure, you have this GSM, which is a global smart listener, which will allow your clients to be routed to the best database based on the policies that you get to set. Right? So your application clients, instead of connecting to the scan listener or the database listener, now they will connect to a GSM listener. Right? And based on the policies you set, whether it's connect time load balancing, whether it's runtime load balancing, these GSMs will take you to the right database for the best performance for your application. Okay? And I'll show you how it's all done in the subsequent slides. And like I said, GSMs are nothing but listeners, right? And we recommend typically 3 GSMs per region. And they don't have to be on a separate servers. You could co-host them on small scale VMs as well, right? But for high availability and scalability, we recommend at least 3 of them per region. Okay, so that's the GDS architecture. Now, in terms of deployment, it's very simple to deploy. I'm showcasing, in this example, I'm showcasing how to configure GDS infrastructure, right? There are about half a dozen steps, right? There's a command called create catalog that you would execute in an interface called GDS CTL. You would specify on what database you want to create this GDS catalog and what are the regions that you have for your application. And you say add GSM. This is to create the global service manager listener, and you specify the listener port and what's the catalog it's mapped to, right? And what region this GSM is residing on. Right? This is one example, and if you have 3 GSMs, you would execute add GSM 3 times on different on different hosts on which these GSMs will be running on. Okay. And then once these GSMs are added, you would start the GSM. Okay. Afterwards, you would add a GDS pool. A pool is nothing but a logical container which contains the database replicas that will go into the pool. Right? What you're doing now is only specifying the metadata. You haven't executed anything, just specifying the metadata of how your GDS will be configured. Okay. So now you added the database to the GDS pool. At this point, you will create a service, the global service. Here in this example, I'm naming sales query service as the service name. And what's the pool that it's going to be running on, which is a pool, GDS pool, which has these two databases, DB01 and DB02, and on which the preferred database is set to as DB01. And if the preferred goes down, then the service will have the opportunity to fail over to the available database DB02. Right? And then once the service is added, you can start the service. Once the service is started, you can use this particular service in your TNS names of your application. Okay. So let me show you how the TNS names would look like. It's no different from what you've been used to today, whether you're using the regular database listeners or the scan listeners, right? So except for in this case, in the address list, you would list out the GSM listener endpoints, right? If I have 3 GSMs in one region, host 1A, 2A, 3A, and their ports, I would list those listener endpoints here in the address list 1, and I'll have a separate address list for the region 2, and I'll specify those listener endpoints as well. Okay, so it's no different from your scans or regular listeners. And all the MAA best practices, max availability best practices, the connect time or the transport connect time or the retry count, retry delay, they all hold good even with GSMs, so that you will have client-side failover and client-side load balancing. When I say that client-side failover, that means if a GSM host 2A is down, we immediately fail over to the next one in the list, right? So you immediately fail over. And if all the listeners in an address list are down, in this bucket are down, sorry about that, you would automatically fail over to another address list and still be able to get connected to any database in the GDS pool. Right? So this is the client-side connect time failover and client-side connect time load balancing. The server side, we're going to talk about in a bit, but this is what we're touching upon is the client-side load balancing and client-side failover. And then in the connect data clause, you have the service name. In this case, you would specify the global service that you've just created, right? And optionally, you can list out the region the client is coming from. And I'll show you why that's relevant, the region, specifying the region aspect. Okay, so this is the TNS entry example when you're using a GDS configuration, right? So now let's touch upon the use cases of how GDS helps in a GoldenGate configuration. So in this example, I'm showing 2 databases, DB01, which is the source, the master, DB02 is the replica, the target. And I have the order entry service that's running on the master. Okay. In this example, the behavior that I want to achieve is if the DB01 goes down, I want my service, the order entry service, to fail over to DB02. Okay. As we've seen this before, to achieve that behavior, I would create the global service with the following parameters: add service, service name, the pool on which this service should be offered on, and what's the preferred, what's the variable. So if the preferred goes down, GDS will recognize it. GDS being the global service manager, which is the core component, it's monitoring these databases, and if it determines that this database is down, it relocates the service to the available database. Okay, in that way, you would achieve higher availability and improved manageability, wherein you fail over the service, and GSMs also let the application know we have FAN notification, the fast application notification, and let the clients know that the service has failed over. So the connection pool clients will receive this notification and automatically react to it, and then route their connections to the database which is offering that particular service. Okay. So that's the service failover for GoldenGate master replica configuration. Now, how about reader farms? Many customers do this. They have one database that's offering the read-write workload, right? That's executing the read-write workload, and they have a pool of databases that those are the replicas of the master. Right? In this example, DB02, DB03, DB04 are the replicas on which there is a read-only workload that's being run, right? Via the reporting service. So my goal is to have load balancing for my read-only workload that's being offered on the reader farm here, right? To achieve that, I create a special service, in this example, a reporting service that's offered on databases DB02, 3, and 4, these 3 databases. And I specify 2 clauses: connection load balancing goal long, and then runtime load balancing goal as service time, right? And these goals are no different from what you had with RAC. RAC always had this support for this connection load balancing and runtime load balancing, but within the instance of a cluster database. But now with GDS, these load balancing goals, CLB and RLB, are the goals that are offered across replicated multiple databases. Okay, so all you would do is create this service as I showed here, and then you would use this service in your TNS names. And all your clients who are using that particular TNS names, which has the service reporting service, will automatically get load balanced across all these databases. Okay, that's the load balancing for reader farms use case. Now, what about load balancing for active-active GoldenGate? And many customers do this again. They run active-active GoldenGate in a bidirectional mode, right? And their application, the assumption in this case is the application handles the multi-master conflict resolution, right? And then the goal in this case is to load balance my workload, both read-write as well as read-only, across these 2 databases. Right? Now, how do I achieve that? So in this case, in the previous example, we showed load balancing for read-only workload. In this example, it's the load balancing for read-write workload, right? So I create my service, order entry service, and then I'll say preferred all. That means it can run on both databases. And the goal that I want to honor in this case is the connection load balancing goal long. Long is for the long-lived connections, right? So when this service is used by clients, all the incoming connections are well balanced across these databases. Okay. So as part of the load balancing algorithm, we leverage few key metrics. The service level metrics, very similar to what you see in AWR, the latencies between the data centers, the goals that you set, right? All this information is leveraged as part of the load balancing algorithms. Okay. So that's load balancing for active-active. What about region affinity? So let's say in this example, I have 2 data centers and they're very far from each other. And they're running bidirectional GoldenGate configuration, right? My goal here is to route my clients closer to data center 1 to a database near data center 1. Likewise, clients near data center 2 to be routed to a database in data center 2, right? How do I achieve that? To achieve that behavior, I would create my global service, in this example, the order entry service, that's offered on the pool sales. Okay, preferred all, that means it can run on any database as long as the locality is local only. That means preference is given to a local database first. For these clients, they always will go to the local database first. And if the database in the local data center is not available, as a second option, you have a region failover. That means you could go across to the other data center as well as a second option, right? So locality, local only is your preferred choice. And if that database is down, you can always go to the second database in the pool. Okay. So now let me touch up on an interesting one. How does GDS know that you're coming from data center 1 or data center 2? Remember in the TNS names example that I showed you, connect data, where you specify the service, and there is also a region clause, right? So that's where you specify, the clients are specifying that I'm coming from east, I'm coming from west, right? That information is determined by GSM, and that's when it knows that, hey, this particular client is coming from data center 1, or for that matter west, and since the locality is set to local only, I'm going to take them to a database in the data center west, or data center 1. Right? So that's how the handshake happens. In the TNS names, you specify the region clause, and on the GDS end, you specify the locality local only. That's when you get routed to the nearest database, so that your performance is in the best possible manner. Okay, that's region affinity with GoldenGate. Now, I said how there is the ways to mitigate downtime when it's planned or unplanned. Let's talk about those. Right now, what kinds of downtime we're talking about? Let's say a database crashes, whether it's unplanned, or for that matter, you took it down and then service has automatically failed over, right? So those are the scenarios we're talking about. To minimize the downtime for that kind of for those kind of scenarios, a few best practices that you want to follow. The applications must be using Oracle integrated connection pools. It could be UCP, it could be OCI, ODB.NET, WebLogic, GridLink, etc. Right? Third-party application servers are also supported as long as you use UCP as a data source. Okay, such as WebSphere and Apache Tomcat. The other best practice that you want to follow is you want to subscribe to the fan events published by GSMs, right? And basically, you would enable the fast connection failover in the example, in the UCP's example. Once you enable FCF, you are basically subscribing to the fan notification, right? Whether it's service failover or whether it's runtime load balancing, your application connection pools receive real-time notifications. And then the TNS entry, as I said before, you should follow all the MA best practices. The retry count, connect timeout, transport connect timeout, so that you quickly fail over if a GSM is down to another GSM. So now unplanned events, these are then planned for GoldenGate. It will be the global service failover. That means a preferred database went down and the service has come up on the available, right? In that scenario, what happens? The moment the service fails over to the second database, the fan notification is published by GSMs, right? And the fast connection failover ensues. So as part of the fast connection failover, your new work is redirected by GSM listeners immediately, right? So GSMs know where this new service is being offered on, and it'll route the new workload to those to that database. Idle sessions that were in the pool, they will be released immediately, and the checked out connections, they receive an invalid connections, and the application closes the connection and opens a new one. But this time, when it opens a new one, they will be going to the second database where the service has come up on, right? So that's how you mitigate your downtime for unplanned outages, right? So as you've seen, there is no big configuration change. All you would use is in your application, whether it's UCP or TNS names, you use the service that you created, you follow the best practices, and you make sure that the fast connection failover is enabled. Okay. So now, how about the planned outage? So I have two databases here, OGG1 and OGG2. And the planned outage could be, I'm applying a database patch or application patch, or for example, infrastructure patch, right? So when I'm ready to apply a patch, I want to move my workload from one database to the other, right? Let's take an example. I'm doing an application patch, okay? So I have two databases, OGG1, OGG2. What I would do is I would patch the OGG2, the second database, right? And then once the patch is applied, I want to move my workload from OGG1 to OGG2. All I would do is run one command from GDS called relocate service command. I'll specify what's my old database and what's my new database, right? And that's how I relocate my workload from one database to another, or it could be from one data center to another data center, right? To get that, I would have definitely follow the same best practices that we touched upon in the previous slide. So in this example, when you run the relocate command, the same scenario happens. The fan event is published to the connection pools, and then fast connection failover drains the sessions gracefully, right? As part of the FCF, your new workload again is redirected by GSM listeners immediately. Idle sessions, of course, are cleansed out. And the active sessions, let's say these are old TP sessions, those will be released when they are completed and they're committed, and then they come back to the pool. That's when they are relinquished. Right? So this happens gracefully as part of the relocate command. Right? So that's how GDS mitigates the downtime both for planned and unplanned events. GDS is a key component of the max availability architecture. There are other components such as RAC, ASM, application continuity, enterprise manager, cloud control, GoldenGate, data guard, recovery appliance, you name it, right? Starting from 12.1, now GDS is a key component there. So we recommend you to, when you're making your application highly available and high performant, we recommend you to try using global data services so that you have the best performance and best availability for your applications. Okay. Before I summarize, one thing I want to touch on, I'm trying to compare GDS with network load balancers. Network load balancers and GDS both allow you to do locality-based routing, connect and load balancing. But because GDS is between the application tier and the database tier, it offers you even additional capabilities. For example, it publishes the runtime load balancing metrics in real time. It publishes the fan notifications if in services failover. And for active data guard, it even does replication lag-based routing. And for GoldenGate, the replication lag-based routing is on the roadmap. It should happen in the subsequent releases. GDS provides service failovers. With active data guard, it also does role-based global services, so that if you do a role transition, whether it's a switchover or failover, the global services also get relocated based on the role that you set for the databases, right? And then centralized management of your database services across Replicas. As I mentioned before, it's a simple interface with which you can set your policies and manage your workload, right? And it's included with Active Data Guard or GoldenGate license. There is no additional purchase that you would have to do, right? Bottom line, GDS provides workload routing, which is the region-based routing, load balancing, both connect time and runtime, service failover within and across data centers, and allows you to manage all your replicas with a simple interface. Key benefits, as we talked about today, with all these capabilities, you get the best performance for your application and best scalability and availability. Scalability for the reader farm use cases. And you can mitigate your downtime, as I said, for planned and unplanned outages. And you have the best resource utilization of your replicated environments. Okay. For additional resources, I strongly urge you to go and check out this particular portal, oracle.com, go to GDS. This is the OTN portal, which has the webcast, the white papers, the cookbooks on how to employ GDS with GoldenGate, and numerous customer presentations as well. Okay, and I strongly urge you to go and check out the blogs that I post frequently here, and do follow me on Twitter at Nagesh Matuna.